Hello there, this is exercise 7A.1 game theory for discrete maths for further maths. And look, game theory sounds on the face of it really exciting, doesn't it? Compared to a lot of maths anyway. And it is definitely interesting, but you don't expect to play lots of games. But one thing I do want to do is just make sure you're aware that of the different aspects that we need. And then we're basing this on the OCR version of discrete maths, decision maths, but they're broadly the same in terms of what you'd be expected to learn no matter which exam board you did. So anyway, look, here's a game for you to play, and I'm going to give you an opportunity to play it, and or just think about it. And the game's called Matching Pennies, and it's meant to be a game which has equal chances of two people winning. So on the one hand, you're going to either spin two coins, or you might just get the two people to opt to play and choose what they want to play, whether it be heads or tails. And based on what they say or they spin, if the two outcomes are the same, then one player wins. Player A, I've written down here, wins. But if the two are different, then the player B wins, i.e. one's a head, one's a tail, then B would win. So if you do the probabilities, you quickly realise you get the same probabilities. And it's an equivalent version of rock, paper, scissors. The only difference, I suppose, with rock, paper, scissors, which I'm sure all of you have played, is rock, paper, scissors allows someone to draw as well. You might win, you might lose, but you might draw. And so rock, paper, scissors sometimes is 2 or 3 goes before you eventually get a winner. Whereas this matching pennies game isn't. So think about that game. If you just think about it for a moment, I suppose you've got player A, which I'll put over here, and he can play head or tail, and player B can also play heads or tails. And head means that A would win, and tail means that A would win. But tail head would mean that B would win, and head tails means that B was in. This is what I meant when I said they've got an equal likelihood of playing. Now, there are other games that you can play rather than just matching pennies game or rock, paper, scissors. Now, let's have a look at a few here. Which of these games would be considered to be two-person simultaneous play games? Now, that's the important line there, simultaneous play games. So the idea is you played at the same time. So look, take chess for instance. Chess, one player plays, the other person plays, one player plays. So this is a no. This is not two players simultaneous play games. Roulette, you quickly think to yourself, hang on a bit, you're either playing on your own or there's lots of people playing, but I don't think it's two-person necessarily. So I don't think that is an example of a two-person simultaneous play game. Rock, paper, scissors definitely is. If you know that game. Football, well, there's two teams, but it's certainly not where you've got a set number of outcomes, I suppose. So I'm going to say no to that. Snap, it's definitely simultaneous play. Is it two-player? Well, it can be. I think this might be regarded as two-player simultaneous play games if there's only 2 players, of course. If there's 15 players, I suppose it makes it more complicated. And we've already talked about this match pennies. I think this one is as well. What did I put down as my answers? No, yes, no, yes. So I'm pleased about that because at least in the snap they agreed that that was a 2-player simultaneous play game. So what I want to do now then is to look at some of these games in more detail. And the first one is this rock, paper, scissors. Rock, paper, scissors, as you know, is 3 different things that you can do. And this picture up here, and I think it was on the first slide as well, this is meant to be the rock when you play the game. Actually, this one is the paper. Nearly tricked me there. And this one is the scissors. Making sure I spell scissors correctly. So rock, paper, scissors, and you should know that, for instance, when the 2 people play, the rock beats the scissors because it bashes it. The scissors cut the paper, so it beats it, and the paper beats the rock. So I suppose that's why it's in that order. Now we can draw this up as what we call a payoff matrix. And the payoff matrix is where we just record, a bit like I just did with the matching pennies game, we record the possible results. But notice here, I'm going to give points now for the winner. The winner gets 2 points, the loser gets nothing, and if they get a draw, they get 1 point each. A bit like if you're playing a football match, I suppose, rather than it being 3 points. So rock, if the two players, player 1 and player 2, both play rock, you should be aware that the first person would get 1 point and the second person would get 1 point. Now, how do we do that? That's probably the best way of doing it is put it in a bracket with like that, almost like a coordinate, but showing the two different outcomes. And so you can just do this. And what I would recommend you do is pause the video and just complete this. I'll do one more, then I'll let you do it. So this one down here, what's this? If paper one, if player 1 plays paper and player 2 plays scissors, well, scissors beats paper. So therefore, player 1 would get nothing and player 2 would get 2 points. So pause the video and then I'll put my answers up. So here's my answers. Let's see if they ping up there. Here they are. So that's I got the 1-1 right. I got the 0-2 right, and hopefully all those other answers there agree with what you've done. So the next thing I need to do is introduce you to this idea of what's called a zero-sum game. You often hear this talked about in literature and popular culture. A zero-sum game is where no one really benefits. So for instance, if I'm betting on the stock market, really all I'm doing is I invest in a company, I hope to make money in that investment. But really all I'm doing is taking someone else's money. Someone pays me more money than I paid. So I've taken someone's money. No one really, in that scenario, wins overall. Well, one person does, but only when someone else loses. So a zero-sum game is one in which for every combination of strategies, the amount that one player wins equals the amount that another player loses. A zero-sum game, it says, has a total for every cell in that payoff matrix that we just saw that equals 0. Now, on the face of it, you've just got to be slightly aware that what we saw before, maybe it didn't look as if it was a zero-sum game. You may recall, in fact, let's go back to it. If you look at this, how am I meant to see whether or not these are a zero-sum game or not? So this is the big question. Now, it says sometimes they don't look like zero-sum games. You've got one person winning, another person winning, perhaps, or perhaps you've got one person losing, another person. So you just got to look at it carefully. But if the total of each cell, it says, is the same, then it possibly is a zero-sum game. And it says subtract half of that number from each value in your matrix to reformulate the matrix. That's what I'm calling a proper zero-sum game. So one that basically looks like a zero-sum game. So let me give you a clue as to what I mean by this. And just note this thing. Rather than the two numbers that we saw just now, let's just go back to it again. We've got two numbers in each cell. It is very common to just show the first person, because by definition, if you know what the first person does, in a zero-sum game, you know what the second player does. So just be aware that we will tend just to show these first numbers or care about the first numbers. We care about what happens to player 1 on the assumption that we know, therefore, what happens to player 2. So here was my answers for the rock, paper, scissors. I suppose before I do this, I need to just think about the pennies game. Let's imagine the pennies game is exactly the same. I suppose the only difference is I've got to decide what to do. So what I'm going to say is I'm going to say if they're the same, or if you win 1 point. That's what I'm going to say. But if you lose a point. So you can make up the point system however it says, or rather lose -1 points. Probably more likely it is the exam question will tell you what the rules are. So in this scenario, I suppose, the player 1, player 2 both play heads. The first person, if you recall, needs them to be the same. So therefore, the first person gets a point, but the second person has lost. So he or she loses a point. And notice at the moment I'm doing both scores, but in a minute I will change that so they're not. Now, what if it's tails? Well, straight away when you see tails with a heads, you know the first person has lost, so that's -1, and the second person has won. Let's do that. So what's that? So that's 1. And then here, it's also different. So that's like that. Don't know what happened there. And then here it's 1 minus 1. Now, I suppose the first thing to do is just check, and we've already seen here that all of these cells on the first rock, paper, scissors game, they add up to 2. So you look at any of them add up to 2. And here I think they all add up to 0. And I did have a rule that said if they add up to the same number, subtract half of that number from each value in your matrix. So I've got to subtract half of that number from each value. So on this first one, I reckon they all add up to 2. Half of that gives me 1, and I'm going to take away 1 from that first number in here. So you should quickly realize when I do this, that 1, I'm going to take away 1, and it's going to become a 0. That 0, well, that will become a minus 1. That 2, that will become a 1. So you just do this, and hopefully that's what I've got here. Yeah, so that 1, knock off 1. That 0, notice again, I only care about the first number. So 1, 0, 2 became 0 minus 1, 1. And now you can see this does look like a zero-sum game to me, because if you look across each row, you can see there's no difference. If it's 0 minus 1, 1. Can you see they add up to nothing? That's the zero-sum game, I suppose. This one, what am I doing here? What do they add up to here? They add up to here 0. Oh, right. So because they add up to 0, well, I meant to subtract half of 0, which is 0. So if I subtract 0, it's the same. So really, this one's just going to be equal to the numbers I've got at the start of my bracket. In each case, let's see if I've got 1 minus 1. Yes, it is. And so you can see there my zero-sum game. Again, if you look across the row, 1 and minus 1 makes 0. Minus 1 and 1 makes, and you could go either up or down. It doesn't make any difference. That is a zero-sum game. So I now need you just to be aware that sometimes we want to write a payoff matrix for player 2. Now, I've already said that invariably, whenever we get those cells like that, and we get a bracket, and it might say 2 and say 1 like that, we care about player 1 most times. So for player 1, you'll notice it's the 2. Player 1 wins 2. And in this game, because it says 2, 1, player 2 would win 1. But I don't particularly care about this. I want to know about the matrix in this scenario very often for player 1. So it's quite common here. You can see this payoff matrix below for a zero-sum game between players 1 and 2 is as follows. And this will be, if there's one number, almost certainly from player 1's viewpoint. So this is for player 1, and it's their viewpoint. So in other words, we know when player 1 plays X and player 2 plays A, player 1 wins 4 points. Now, because it's a zero-sum game, of course, I can know what happens to the other person. And because it's a zero-sum game and it's been written properly, I suppose that's the critical thing as well. Really, I can think of this as being 4 minus 4. It doesn't say 4 minus 4, but it means 4 minus 4. You need to know that what happens to 1, because it's a zero-sum game. If player 1 wins 4, player 2 loses 4. That must be. This one presumably is 0, 0. Etc., etc. So the numbers have to be changed. Now, I can do this in 2 ways. I suppose the best way to do it will be to rewrite it. To rewrite it from player 2's perspective. We put player 2 over here. And now I suppose I've got an A, B, and a C coming down here. An A, a B, and a C. And across the top I've got X and Y for player 1. And I suppose all I need to do is just change all these numbers. So that 4 there becomes a minus 4. Got to be slightly careful. Obviously, it helps that it's different sizes, different dimensions in each direction. But I think that XB now goes there. That's a 0. And that 2 there, the XC, it says 2, so therefore it's minus 2. And these just go 2, minus 2, and 3. They just change signs. So just be aware that if we change it, it's probably best, if we're going to do player 2's viewpoint, to switch them round in terms of which one's going down, which one's going across. Let's see. Yeah, that does all look fine. So look in the booklet now. Those of you using the booklet, we're going to do a couple more of these, but then we'll basically finish this. So these are the questions for those of you not in my class that we'll just play over. There's a couple of examples to practice with. In class we'll do those if you're with me. And I suppose then now it's your job to have a look at the second in this game theory videos, because there's certainly a lot more. Thanks a lot for watching, and see you soon.